Today is 1.1 number patterns. Our chapter 1 essential question is how can you add and subtract whole numbers and decide if an answer is reasonable? We're going to dig even deeper, and today for 1.1 we're going to ask how can you use properties to explain patterns on the addition table. Some vocabulary terms that you'll see is commutative property of addition, identity property of addition, and pattern. For commutative property of addition, it is when you add two numbers and it doesn't matter what order the numbers are in, the sum is going to equal the same thing. For an example, 3 plus 4 equals 4 plus 3. They both equal 7. The next one is identity property of addition. This is when you add any number plus 0 and it will equal that number. For example, 7 plus 0 equals 7, or 0 plus 5 equals 5. The other vocabulary term you'll see is pattern. It is when an ordered set of numbers or objects, the order helps you predict what will come next. Your I can statement today is I can identify and describe whole number patterns and solve problems. Our first problem of the day is Karen picks 3 apples. Ty picks 5 apples. How many more apples they need to pick to have 12 apples altogether? So I see the number 3 and 5 and 12. So I have 3 numbers. That clues me in, telling me that this is probably going to be a 2-step word problem. I also know that the last word altogether is here, so that means that I probably need to add. So Karen has 3 and Tiny has 5. So when I put those two together, 3 plus 5, and that equals 8. That is a choice down here, but I know my work is not done because I did not do anything to this 12. I'm needing to find now how many more. So how many more clues me into knowing that this is probably a subtraction problem. So I had 3 plus 5 equals 8, and I have 12 left over. So that means that I probably need to take 12 and subtract 8. When I take 12 and subtract 8, that equals 4. So my answer is 4, letter B. You try writing this on your paper. Great. If you need to pause the video for more time, you may, or we will go on to the next problem. Today we're going to be working on addition problems. This is an addition table. We are going to look at patterns that we see on the addition table. So look across each row and down each column. So here is the rows, and here is the columns. Rows are side to side and columns are up and down. What is the pattern with this? The numbers increase by 1. 1, 2, 3, and so forth. When I shade these numbers, they will both increase the same. So if I look at this column, this is going to go across and increase by 1, and this is going to increase by 1. I also notice that when you look at numbers and you go diagonally, they are either even or odd. We will look into this a little more in a little bit. What happens when we add a 0? Just like when we worked on the identity property of addition, when you're adding 0, so like 1 plus 0, so here's 1, here's 0, it's going to equal 1. So it will be the same number that is included in the question. So how you use the addition table is you will have 2 fingers and you'll meet them in the middle. So if it was 1 plus 1, here's 1 and here's 1, they meet right here. So 1 plus 1 equals 2. Let's try a harder problem. Let's do 9 plus 7. So if I find 9 here and I find 7 here, they meet in the middle, 9 plus 7, and that would equal 16. What we talked about earlier with patterns of odd and even, it is also in the number sentence. So when I add 4 plus 2, it equals 6. 4 is what kind of number, odd or even? You're right, it's even. Also, what is 2? Odd or even? It is even. So when I have two even numbers added together, the answer will be even. Let's look at this problem. 4 plus 3 equals 7. 4 is an even number, but 3 is an odd number. So when we add an even and an odd number, it will be odd. Let's look at our final problem. 5 plus 3 equals 8. 5 is an odd number, and 3 is an odd number. When we add those two together, we will get an even number. This concludes Lesson 1.1.